There's a chimney breast in the bedroom, no fireplace, no stove, no insert, just a sealed rectangle of brick that disappears into the ceiling. You tap it, solid, you check the floor below, nothing. You go up to the attic, the stack keeps going, exits the roof, looks exactly like every other chimney on the block. It connected to something. It still exists. And in most old houses, nobody ever figured out what to do with it. What you're looking at isn't a design quirk, it's infrastructure. And what's inside it is a different story entirely. That chimney breast isn't one thing. It never was. In a Victorian house or an early 20th century build, the chimney stack was the nervous system of the entire structure. What looked like a single column of brick from the outside contained anywhere from 2 to 6 separate internal passages, each one a dedicated flue serving a different heat source on a different floor. The parlor fireplace had its own flue. The kitchen range had its own. Each bedroom fireplace had one. The servants' quarters had one. In larger houses, the boiler had one too. All of them ran upward through the same brick mass, kept separate by thin walls of mortar and brick inside the stack, sharing the same exit point above the roofline. The logic was sound. Build one structure, run everything through it. Share the materials, share the labor, share the maintenance. The chimney was permanent by design, and it was in the sense that it is almost certainly still standing in your house right now. But here is what happened. Central heating arrived. Gas cookers replaced coal ranges. Electric fires replaced bedroom hearths. One by one, each heat source that fed into the chimney stack was decommissioned. And one by one, each flue that served it was capped, sealed, or simply abandoned in place. Not removed, not demolished. Just closed off at the bottom and left. The brick mass that once served an entire household, cooking, heating, ventilation, hot water, now serves nothing. But nobody took it down. Taking it down meant opening the roof, restructuring the floors it was tied into, replacing the support it provided to the joists framed against it. It meant a project that cost more than the problem it solved. So, the chimney stayed. It always stays. What most buyers never realize when they walk through an old house is that the chimney breast they're looking at is not a single object with a single history. It's a compressed archive. Each sealed flue inside it represents a different era of domestic life, a different way people cooked, heated rooms, and moved air through spaces that had no mechanical systems to do it for them. The parlor flue remembers the coal fire. The range flue remembers the kitchen that no longer exists on that side of the house. The narrow ventilation passage nobody can explain remembers the interior bathroom that was added in 1910 and ventilated through the stack because there was no other option. You tap the wall and it sounds solid because it is solid, but solid doesn't mean empty, and empty doesn't mean safe. Behind that plaster, inside those sealed passages, things have been accumulating for longer than anyone currently living in the house has been alive. The chimney outlived the fires. It outlived the people who built it. And in most cases, it will outlive the renovation budget of whoever owns the house right now. The brick mass that once served 6 purposes now serves 0. But it's still there. It still takes up floor space on every level. It still anchors against your joists. It still exits through your roof. And inside it, inside those sealed passages that nobody has opened in 50 or 80 years, things have been happening that nobody thought to account for when they pushed that metal cap into the opening and replastered the wall. The chimney outlived every single thing it was built to serve. Take the kitchen range flue specifically. The Victorian cast iron range was not a small appliance. It was a permanent fixture, bolted down, plumbed for water in later models, burning coal continuously from morning until the last dish was washed. It ran hot enough that the dedicated flue it required was often wider than a standard fireplace flue, sometimes built with a larger throat to handle the volume of combustion gases coming off a fire that never really went out. The range was the heart of the Victorian kitchen in a way that no modern appliance comes close to replicating. It heated the room. It heated the water. It dried the laundry, hung above it. It was never off. And the flue it demanded was built to match, wide, tall, direct, designed for continuous heavy use across decades. When gas cookers became accessible in the 1920s and 1930s, the range was removed. The flue stayed. In houses where the kitchen was later renovated, moved to another part of the ground floor, extended into the rear, or completely reconfigured, the original range flue now exits the chimney breast in a room that was never a kitchen. You see the chimney breast. You look for the fireplace. There isn't one. There was never a fireplace there. There was a massive iron range on the floor below, in a room that is now a dining room or a utility space, and the flue ran straight up through what is now your spare bedroom wall. Nobody relocated the flue when they moved the kitchen. Nobody filled it in from the top. They capped it at the bottom with a metal plate or a brick, replastered over the opening, and left the full height of the passage, raw brick, unlined, open to the roof space above, sitting inside the wall of a room that has no idea it was ever connected to a working kitchen. At the bottom of that sealed column, decades of grease residue, coal soot, and the slow infiltration of moisture from a stack that lost its internal warmth the day the range went cold. The range is gone. The smell of what it burned is still working its way through the mortar. That is the version of this story that ends with a damp survey and a confused contractor. But it is not the only version. Some of these sealed flues don't just contain what accumulated passively over time. Some of them contain what someone put there deliberately, during a renovation, in a hurry, when removal was expensive and the wall was right there and nobody was ever going to open it again. That part of the story comes later, and it changes how you look at every chimney breast in every old house you will ever walk through. At the bottom of that flue, a metal plate or a brick cap, or in some cases just a layer of plaster over the opening. Above it, decades of accumulated coal soot, grease residue from years of cooking, and raw brick all the way to the top of the stack with no clay liner because range flues often weren't lined. They were just open brick passages because nobody in 1890 was thinking about what happened when the range eventually left and the moisture didn't. The range is gone. The smell of what it burned is still working its way through the mortar. The bedroom fireplace flues tell a slightly different story. In any Victorian house with any pretension to comfort, every bedroom had its own fireplace. Heat was not shared and centralized. It was personal and local, a fire you lit in your own room, in your own grate, controlled by your own hand. The fireplace was also, in many cases, the only ventilation that room had. Building regulations and basic livability both depended on the flue providing an upward draw that pulled stale air out of the space. Without it, the room was essentially sealed. When central heating made bedroom fires unnecessary, a process that accelerated through the 1930s, 1940s, and 1950s depending on where you lived and what your house was worth. The fireplaces were closed off. The grates were removed or boarded over. The flue opening was capped. And the flue above the cap, the long vertical passage rising through the chimney mast to the top of the stack, was simply left there. Cold, sealed, with no fire below it to create a draw and no ventilation above it to release moisture. Condensation built up inside the flue. Cold air sat in the sealed passage. When warm air from the room made contact with the cold brick around the flue, moisture migrated into the surrounding masonry. You saw a damp patch appear on the chimney breast wall. You called someone about a roof leak. They checked the roof. The roof was fine. You called someone about a plumbing issue. The plumbing was fine. The actual source was a cold, sealed, moisture-laden flue sitting inside your wall, a passage that once vented itself continuously through heat and draw and now had no mechanism to dry out. What made it worse was how long the diagnosis took. The damp patch didn't appear overnight. It built slowly, over months or years, spreading outward from the chimney breast in a pattern that looked like penetrating damp from outside. Decorators painted over it. The paint bubbled. They painted over it again. The plaster softened behind the surface. Eventually, someone opened the wall, found saturated brick and black efflorescence tracking down the mortar joints, and finally understood that the problem was not coming from outside the house at all. It was coming from inside a passage that had been sealed for 30 years and left with nowhere to breathe. The flue that once kept the room livable had become the reason the wall was failing. The feature designed to move moisture out was now the reason moisture had nowhere to go. They sealed the smoke in and forgot that the wall still needed to dry. Open that chimney breast and you find saturated brick, black efflorescence leaching through the mortar joints, And in older houses, no liner at all. Just wet brick, all the way up. They sealed the smoke in and forgot that moisture was still looking for a way out. And then there is the structural question, which is where things stop being inconvenient and start being expensive. The chimney breast in a pre-1950s house is not decorative. It is load-bearing. In many builds, the chimney stack was the element that floor joists were framed against. It provided lateral support for the wall structure around it. The mass of the stack contributed to the stability of the roofline. Removing it is not a cosmetic decision. It is a structural project. If you want to remove a chimney breast to open up a room, to get rid of that rectangular brick intrusion into your living space, you are looking at installing steel beams to replace the support the breast was providing to the floor structure above. If the stack continues above the floor you're removing the breast from, you need to support what remains. If you are removing the breast on the ground floor but leaving the stack above it, you need steel and possibly underpinning, and certainly building regulations sign-off in most jurisdictions. Partial removal, taking the breast out on one floor while leaving it on others, is one of the most structurally dangerous amateur renovation decisions documented in older housing stock. The breast is removed. The stack above it, which the person assumed was self-supporting, is not. Cracking follows. In more serious cases, movement follows. Insurers in many markets now ask specifically about chimney breast removal history before extending coverage because the consequences of doing it wrong are expensive and the documentation proving it was done right is often missing entirely. The people who do this rarely intend to cut corners. They look at the chimney breast, they see brick, and they assume brick is self-supporting. It is, until it isn't. The stack above a removed breast is now cantilevered off the floors on either side of the gap. Floors that were never designed to carry that load. The movement, when it comes, starts small. A hairline crack above a door frame, a window that suddenly sticks, a gap appearing between the ceiling and the wall. By the time those signs are visible, the structural shift has already happened. The repair at that stage is not a steel beam. It's a structural engineer, a party wall surveyor, and a bill that makes the original chimney breast look like a reasonable use of floor space. And the documentation problem compounds everything. Building regulations require sign-off for chimney breast removal. That sign-off requires inspection. But in houses that have changed hands 2 or 3 times since the work was done, the paperwork has often disappeared entirely. The buyer's surveyor flags the removal. The seller has no records. The insurer wants proof of compliance. Nobody has it. The house is now harder to sell, harder to insure, and more expensive to certify than it would have been if the chimney breast had simply been left alone. You wanted an open-plan living room. The house had structural opinions. Everything covered so far, the moisture, the orphaned flues, the load-bearing complications, that's the inconvenient version of this story. The expensive version. The version that ends with a damp survey and a steel beam quote and a conversation with a building's insurer about paperwork that no longer exists. But some of these sealed flues aren't just structurally complicated or quietly wet. Some of them contain things that were put there deliberately during mid-century renovations by people who needed a place to put something and found a sealed cavity that nobody's was ever going to open again. That version of the story is considerably worse. If you want to know what's actually inside them, stay with me. If you sealed a passage in a wall and never opened it again, you probably assumed nothing would happen inside it. That assumption is reasonable. It is also wrong. Before we get to what people put into these flues deliberately, it's worth understanding what they were already doing on their own, because the passive history of a sealed chimney flue is strange enough before anyone starts using it as a disposal route. Victorian architects were practical people working with limited materials and a strong preference for solutions that didn't require additional construction. When they encountered a problem, a room with no external window, an interior bathroom with no ventilation, a servant's closet that had no natural air movement, they reached for the nearest available infrastructure. And in a Victorian house, the nearest available infrastructure was always the chimney stack. Purpose-built ventilation flues were a standard feature of the period, and most people who live in old houses have no idea they exist. These were not flues for fires. They carried no smoke. They were narrow passages, sometimes as small as 4 inches across, running from interior rooms directly into the main chimney mass, designed to use the heat of the adjacent fireplace flues to create an upward draw that pulled stale air out of spaces that had no other exit. The physics worked. A warm flue creates a draft. That draft pulls air from any connected passage. Connect a small duct from your interior bathroom to the side of the chimney mass, and the bathroom ventilates passively without mechanical help for as long as the fire in the adjacent flue is burning. The problem is, what happened when the fire stopped? When the fireplace flues were sealed, the heat that drove the ventilation draw disappeared. The small ventilation passages that connected interior rooms to the chimney mass didn't disappear with it. They were just there, brick-to-brick openings, unlined, running through the chimney mass and connecting rooms that were never meant to be connected to each other, or connecting rooms to the cold, open roof space above the sealed stack. In houses where these passages were never sealed at the room end, you get cold air coming in through what appears to be a solid wall. You get smells migrating between rooms with no obvious explanation. You get an interior bathroom that seems to pull air from somewhere and nobody can determine where the draft is originating. Gas safety assessors working in older housing flag these unmapped ventilation connections regularly, not because they're dramatic, but because in a house where a gas appliance has been installed, a hidden passage connecting that room to adjacent spaces is a pathway for combustion products that nobody mapped, nobody sealed, and nobody is currently maintaining. The house was breathing through passages nobody remembered to close. Now open the flue itself. A contractor tasked with opening a Victorian chimney breast that has been sealed for 60 years is not opening an empty space. The interior of a long-sealed flue is a record of everything that passed through it and everything that accumulated once the passage stopped. Compacted soot, dried into loose blocks that crumble when disturbed. Tar deposits that have solidified over decades into resin-like masses coating the flue walls, black, dense, and releasing particulate the moment air movement disturbs them. In flues where a clay liner was added in mid-century, a common improvement from the 1940s and 1950s, sections of that liner may have cracked and collapsed inward, sitting in fragments at the base of the flue or wedged partway down the passage. Then there is the biological material. A chimney cap that has been in place since 1960 and has never been inspected has likely cracked. The original mortar flaunching around it has probably failed in at least one place. Birds found the gap. Jackdaws, starlings, and pigeons are the most common culprits in British housing stock. In American homes, chimney swifts and various corvids. Nesting material accumulates at the point where the gap is, sometimes at the top of the stack, sometimes further down where the flue narrows. In long-sealed flues, you can find nesting columns several feet deep, compressed by gravity and years of additional material, being added from above, inhabited and abandoned across multiple seasons. At the very bottom, behind the sealed cap or the metal plate or the plastered-over opening, you sometimes find the objects present at the moment of sealing. Tools left in the flue during the capping work, mortar bags pushed in to block the opening, rags used to wipe the opening clean before plastering over it. In some cases, objects that fell into the flue during original construction and were simply left there, because retrieving them would have required dismantling work that nobody was willing to authorize. The soot itself, in houses with a coal-burning history, is not a neutral material. Coal combustion produces polycyclic aromatic hydrocarbons, PAHs, as byproducts, and those compounds are present in the accumulated soot inside any coal-era flue. For a contractor opening a sealed chimney breast without preparation, the release of that particulate is an occupational hazard. Respiratory protection, containment sheeting, and careful disposal are standard procedure for any competent specialist. It is not standard procedure for a homeowner who decides to open a chimney breast themselves on a Saturday morning with a hammer and no face mask. You thought you were opening a wall. The wall had been storing things. Above the sealed flue, on the roof, the stack has been standing in full weather exposure for the entire period that the flues below it have been out of use. And here is the part that most people don't consider when they seal a chimney and move on. An active flue is warm. The heat rising through it keeps the surrounding brickwork relatively dry. The moisture that penetrates the mortar joints from outside evaporates. The stack stays stable because the temperature differential between inside and outside is managed by the continuous passage of warm air. Seal the flue. The warmth stops. The stack is now cold all the way through. Moisture that penetrates the mortar joints in the stack, and moisture always penetrates mortar joints because mortar is porous, has no heat source to evaporate it. Freeze-thaw cycles in winter work on the saturated mortar, expanding it, cracking it, pushing the joints open. The pointing fails. The flaunching around the chimney pot or cap cracks. The cap itself, if it's the original terracotta, lifts slightly or fractures. And now water has a direct entry point into the sealed flue below. Water enters at the top. The sealed flue has no exit. The moisture migrates laterally into the chimney breast brickwork. It moves downward through the stack, following the path of least resistance, appearing as a damp patch on the chimney breast wall inside the house. On the first floor, the second floor, wherever the water finally reaches equilibrium. You see the patch and you think roof leak. The roofer checks the roof and finds nothing wrong. The damp surveyor checks the external walls and finds nothing obvious. Nobody looks at the sealed flue because nobody thinks of the sealed flue as a plumbing problem. It isn't, exactly. But it behaves like one. Repointing a chimney stack requires scaffold or a cherry picker. In most markets, the cost runs between $1,500 and $4,000, more for taller stacks on multi-story houses. Most owners defer the work until the interior damage is already visible. By that point, the repair is the repointing plus the interior remediation plus, in some cases, relining what remains of the flue to prevent the same thing from happening again. They sealed the bottom and forgot the rain was still coming in at the top. And now, the part that reframes everything. During the mid-century renovation boom, particularly the 1950s through the 1970s, when older houses across both Britain and North America were being modernized, insulated, and stripped of their Victorian fixtures, contractors and homeowners faced a practical problem. The materials being removed from these houses had to go somewhere. Asbestos-containing materials were everywhere in mid-century construction. Loose-fill asbestos insulation poured between joists, asbestos millboard used as heat-resistant sheeting around fireplaces and stoves, asbestos rope packing used to seal the gaps around range inserts and boiler connections. When these materials were stripped out during renovation, proper license disposal was expensive, complicated, and in the early decades of the asbestos awareness period, not yet universally enforced. The sealed chimney flue was an obvious solution. It was already inside the wall. It was already sealed at the bottom. Nobody was going to open it. You pour the loose fill down from above. You push the millboard sections in through the capping opening before you replaster. You leave the rope packing at the base of the flue where you found it, because removing it would mean a day's extra work, and nobody authorized a day's extra work. You cap the flue, plaster the wall, move on. Environmental assessors working in pre-1980 housing find asbestos-containing materials inside chimney flues and chimney breast cavities with enough regularity that it is now a standard item on a pre-demolition hazardous materials survey for any house of that age. The chimney breast that looks like a solid brick wall, painted, plastered, decorated across 3 or 4 subsequent ownership cycles, is, in some of these houses, a sealed container holding licensed hazardous material. Removal requires a licensed contractor. In most jurisdictions, the presence of asbestos in a chimney flue is a disclosure obligation in a property sale. In cases where the material is accessible and can be removed cleanly, the cost of licensed removal and disposal runs into the thousands. In cases where the material is distributed through the flue in ways that make clean removal impractical, the recommended approach is often encapsulation, drywalling the chimney breast permanently into the room and disclosing it as a contained hazard because the cost and risk of opening it exceeds the cost of sealing it and telling the next buyer what's inside. The chimney that didn't lead to any fireplace turned out to be leading somewhere worse. Pull back from all of it: the sealed flues, the saturated brickwork, the stack deteriorating in full weather, the contents nobody mapped, and what you're actually looking at is the physical record of how a house was used, modified, and handed forward across a century of occupancy. Every sealed flue is a chapter in that record. The range flue tells you where the kitchen was before someone moved it. The bedroom flue tells you when central heating arrived and how quickly comfort was redefined. The ventilation passages tell you how architects solved problems before mechanical systems existed. The soot tells you what the house burned. The contents of the sealed cavity tell you how a later generation handled the cost of its own renovations. The house didn't preserve these things carelessly. It preserved them because nobody ever built in a way that assumed the future would want to undo the past. The permanence was the point. The chimney was meant to outlast everything around it. It did. Old houses aren't full of mysteries. They're full of answers to questions nobody thought to ask before they sealed the wall. If this one made you think differently about that chimney breast in your spare room, you already know what to do.